Hello everyone, welcome back to WarTech Vanguard. Imagine a fighter jet so advanced that enemy radar systems struggle to even detect its presence. A combat aircraft that can think with artificial intelligence, coordinate with drones in the sky, and strike targets hundreds of kilometers away before the enemy even realizes it is under attack. Today we are diving into one of the most ambitious military aviation projects ever planned by the United Kingdom, a next-generation stealth fighter expected to enter service around 2035. This aircraft is designed to replace and redefine the future of aerial warfare. Britain, along with partners like is building a fighter jet that combines stealth, artificial intelligence, hypersonic data processing, and drone teamwork. This is not just another fighter jet. It is a glimpse into the future of warfare. The exterior design of the Tempest revealed a completely new philosophy of stealth and aerodynamics. Unlike traditional fighters, the aircraft is expected to feature a smooth, blended body with sharply angled surfaces that scatter radar waves away from enemy detection systems. The design reduces radar cross-section to an extremely low level, similar to or potentially even smaller than aircraft like the ETA. According to information released by industry partners, the Tempest will also integrate advanced radar-absorbing materials that make the aircraft extremely difficult to detect using conventional radar systems. Its wide Delta-style wings provide both stealth advantages and high maneuverability at supersonic speeds. Another striking feature is the aircraft's internal weapon bays. Instead of carrying missiles on external pylons which increase radar visibility, the Tempest will store weapons inside its fuselage. This allows it to remain stealthy while still carrying advanced air-to-air and air-to-ground missiles developed by engineers are also exploring adaptive air intakes and heat management designs to reduce infrared signatures, making it harder for heat-seeking missiles to track the aircraft. Inside the cockpit, the Tempest introduces a completely digital environment designed around artificial intelligence and pilot assistance. Instead of traditional instrument panels, the aircraft will feature a large, augmented reality display that can project critical combat information directly onto the pilot's helmet visor. This system allows the pilot to see radar data, enemy positions, and targeting information without looking down at screens. Voice commands and gesture controls are also expected to be part of the interface, reducing the workload during high-speed combat situations. The cockpit may even operate in a virtual cockpit mode, where digital displays can change based on mission requirements. When it comes to performance, the Tempest is expected to push the boundaries of fighter aircraft capability. The engine being developed by is designed to deliver significantly higher electrical power than current fighter engines, enabling the aircraft to operate energy-intensive systems, such as directed energy weapons and advanced electronic warfare equipment. Early technical projections suggest the fighter could reach speeds exceeding Mach 2 while maintaining long-range endurance through efficient engine performance. According to development statements from industry partners, the Tempest will also have the ability to control multiple autonomous drones, sometimes referred to as loyal wingman aircraft. These drones can scout ahead, jam enemy radar, or even carry additional weapons, effectively multiplying the combat power of a single fighter pilot. The aircraft will also integrate a new radar system being developed by that can process massive amounts of data in real time, potentially detecting targets hundreds of kilometers away while remaining difficult to jam. Safety and survivability are central elements of the Tempest program. Modern air combat environments are extremely complex, with advanced surface-to-air missile systems and electronic warfare threats. To survive in this environment, the Tempest will rely heavily on sensor fusion technology. This means data from radar, infrared sensors, satellites, and drones will be combined into a single tactical picture for the pilot. Artificial intelligence will analyze threats in real time and suggest the safest flight paths or countermeasures. The aircraft is also expected to include advanced electronic warfare systems capable of disrupting enemy radar and missile guidance. These systems can confuse incoming threats by sending false signals or altering the aircraft's electronic signature. Another important safety feature is redundancy in flight control and mission systems, ensuring the aircraft can continue operating even if part of the system is damaged during combat. What truly makes the Tempest stand out are its unique selling points. One of the most revolutionary concepts is its ability to operate either with a pilot or potentially without one in certain missions. Engineers involved in the program have explored the idea of optionally piloted operations, allowing the aircraft to perform extremely dangerous missions without risking a human life. Another major innovation is the digital design process used during development. According to, engineers are using advanced digital engineering tools and simulation environments to design and test components faster than traditional aircraft development methods. This approach could significantly reduce development time compared with earlier fighter programs. The Tempest will also be part of a broader defense ecosystem called the Future Combat Air System, developed by the United Kingdom and international partners. In this system, fighter jets, drones, satellites, and cyber systems all work together as one connected network, sharing data instantly across the battlefield. Now let's talk about the price, because developing a sixth-generation fighter is one of the most expensive technological efforts any nation can undertake. The overall program, which is now part of the multinational, is expected to cost tens of billions of pounds over its lifetime. While the exact unit price of the Tempest has not been officially because the Tempest includes advanced AI systems, new engines, and cutting-edge sensors, its final price per aircraft could be considerably higher once production begins in the 2030s. As we move toward the conclusion, it becomes clear that the Tempest represents far more than just another fighter jet. It symbolizes a transformation in how air combat will be fought in the coming decades. Artificial intelligence will assist pilots in decision-making. Autonomous drones will expand the reach of fighter squadrons, and stealth technology will make detection increasingly difficult. Projects like this also demonstrate how international collaboration is shaping modern defense technology, with companies and governments working together to build systems that no single nation could easily develop alone. If the development timeline remains on track, the Tempest could enter service around 2035 and become one of the most advanced combat aircraft ever created. And that raises an important question for the future of air warfare. When fighter jets can think with AI, coordinate with robotic teammates, and operate in a fully connected digital battlefield, how will military strategy change? The Tempest program suggests that the next generation of aerial combat will be faster, smarter, and far more networked than anything we have seen before. For aviation enthusiasts and defense analysts alike, this project is one of the most fascinating technological developments to watch over the next decade. If you enjoy learning about the future of military technology and next-generation weapon systems, make sure you stay connected with WarTech Vanguard, because we continue exploring the innovations that will define the battlefields of tomorrow.